Hi, in this video, we are going to look at 10 problems which are for JEE Advanced and they cover the topics of conic sections. So these will be problems on all three conics and we'll look at some advanced problems and try to learn and revise what we have done so far in the videos. So the course for conic sections is done. We will continue with videos on straight lines and circles in the next few days. But right now I want to conclude this section by doing some advanced problems. So we start off with this problem. Ax squared plus 2hxy plus by squared plus 2gx plus 2fy is equal to 0 is a hyperbola whose center is 1 comma 2 and passes through 2 comma 4. If the asymptotes of the hyperbola are parallel to the lines 2x plus 3y equals 0 and x plus 2y equals 1, then we have to find the greatest integer function of f by g. Okay. So an equation has been given and it has been said that it's a hyperbola. The center of the hyperbola is 1 comma 2 and the hyperbola passes through 2 comma 4. And then they have given also that asymptotes are parallel to the lines 2x plus 3y equals 0 and x plus 2y equals 1, right? So now here you need to remember the theory we had discussed, that equation of pair of asymptotes. Equation of pair of asymptotes to the hyperbola. Standard hyperbola, the equation of pair of asymptotes was this. And we know that equation of hyperbola was x square minus a square minus y square by b square equals 1. And we said that the equation of hyperbola and the equation of pair of asymptotes differs by a constant. Differs by a constant. So here, if you have asymptotes parallel to these lines, the equation of the asymptotes can be found, right, with some constant. So we can say that since they are parallel to these lines, we can say 2x plus 3y minus k1 is equal to 0 and x plus 2y minus k2 equals 0. These will be the equations of my asymptotes. Here k1 and k2 are unknown because we don't know the actual equations. We only know that they are parallel to these lines, right? So if we know the two equations of the asymptotes to the hyperbola, we can make the equation of pair of asymptotes to this hyperbola, right? So what we can say is equation of pair of asymptotes would be 2x plus 3y minus k1 multiplied with x plus 2y minus k2 equals 0, right? So now that we know the equation of pair of asymptotes, we can say that equation of hyperbola will be this equation plus some constant. So it should be 2x plus 3y minus k1 x plus 2y minus k2 plus lambda equals 0. Why? Because the equation of the hyperbola and equation of pair of asymptotes will differ only by a constant, right? Now, what we can do is simplify this relation, multiply it out, and we will get, after multiplying, you will get this 2x square plus 7xy plus 6y square plus x times minus k1 minus 2k2 plus y times minus 2k1 minus 3k2 plus k1 k2 plus lambda. After multiplying this equation, we get hyperbola equation like this. And now we have been given in the problem the hyperbola equation. It was like this. And we can say that the two equations must be identical. Actually, there was no constant. So this was the hyperbola equation. So the two equations must be identical. Therefore, from here we can figure out that A is equal to 2, B is equal to 6, H is equal to 7 by 2, 2G is equal to minus K1 minus 2K2, and 2F is equal to minus 2K1 minus 3K2. And you also have K1, K2 plus lambda is equal to 0. By comparing the two equations, we got this information, right? Now, we also have to use the fact that the hyperbola center is 1 comma 2 and it passes through 2 comma 4. So how do we do center of a hyperbola? We have to do it by partial derivatives, right? So the method of finding the center we have already discussed. So this is my equation. If you take partial derivative with respect to x, you get 2ax plus 2hy plus 2g is equal to 0. And if you take partial derivatives with respect to y, you get 2hx plus 2by plus 2f is equal to 0. These two equations, if you solve, you should get 1 comma 2, right? Which is the center. So that means 1 comma 2 lies on these two equations, right? So let's see what comes from there. If you put 1 comma 2 in these two, you'll get basically ax plus hy plus g equal to 0 is my equation, and hx plus by plus f is equal to 0 is my equation. And we already know that 1 comma 2 lies on these. So it will be a plus 2h plus g equals 0. And from here it will be h plus 2b plus f is equal to 0. But we already have found the value of a as 2, b as 6, and h as 7 by 2. So we can put that back here, and what we will get is 2 plus 7 plus g is 0. So g is minus 9. And we also get 7 by 2 plus 12 plus f is 0. So f is coming out to be basically minus 31 by 2. So just because we know the center and we know the method to find the center, and we have already found A, B, and H, we are able to get the values of G and F. And therefore, the GIF of F by G becomes minus 31 by 2 divided by minus 9 GIF. So that is going to be 31 by 18. So GIF will be 1. And that is the answer. Notice that we did not even use the fact that the hyperbola passes through 2 comma 4. If you wanted to find the full equation of the hyperbola, you will need to use that, because then we will be able to get the value of k1, k2 plus lambda. You need to find k1, k2 and lambda, right? But for now, the problem is solved. What was the key idea that we used here? We said that the equation of hyperbola and the equation of its asymptotes will differ by a constant. So we found the equation of pair of asymptotes and added a lambda to it and got the equation of the hyperbola. And from there, we said that we will get the values of a, b, and h by comparing coefficients, right? Okay. And also the method of partial derivatives to find the center of any conic. That is also something that we did. Okay, let's move on to the next problem. This says, if a variable tangent of circle x square plus y square equals 1 intersects the ellipse x square plus 2y square equals 4 at points P and Q, if the locus of the point of intersection of the tangents, intersection of the tangents at P and Q is a conic C, We have to find out among these options. C is hyperbola, C is ellipse, eccentricity of C is root 3 over 2, or eccentricity of C is 1. These are the four options that have been given, and multiple options could be correct. So what is it saying? We have a circle x square plus y square is equal to 1. A variable tangent has been drawn to that circle and it intersects the ellipse at 2 points P and Q. We have to find the locus of point of intersection of tangents at P and Q, right? So let's draw a rough figure. This is my circle, let's say, and the ellipse will have major axis of 4. So a square is 4. So it will be a ellipse like this. Minor axis would be 2 root 2. So ellipse is like this, right? Now, a variable tangent. So make a tangent to the circle like this, and this point becomes P and Q, right? This is a variable tangent to the circle. And we have to find the locus of point of intersection of tangents to the ellipse at this point. So this point becomes my R, which is h comma k. We need the locus of R, right? Tangents to the ellipse at P and Q, right? Okay. So how do I make a variable tangent to the circle? X square plus y square is equal to 1. We can take the tangent to the circle at the point theta, the parametric point theta, which will be cos theta comma sine theta. And the equation of the tangent would be x1 plus y1 is equal to 1, which will be x cos theta plus y sine theta equals 1. This is the equation of my variable tangent. This equation basically represents this line. If you call this point T, it represents line PTQ, right? Now, think about it. Since R is the external point from which two tangents have been drawn to the ellipse at P and PQ is like the chord of contact for the ellipse with respect to the point R, the equation of PTQ can also be written in terms of h comma k by using the chord of contact formula. So PQ is chord of contact of ellipse with respect to point R, h comma k. So therefore the equation of chord of contact would be what? XH plus 2yk equals 4. So basically xh by 4 plus yk by 2 equals 1. This is the equation of chord of contact. And basically this line should be the same as this line, right? Because both are representing the same line. So now what we will do is we'll compare these two line equations and find the locus of h and k. So basically we have two lines, x cos theta plus y sin theta equals 1. And the same line has also been written as xh by 4 plus yk by 2 equals 1. So now comparing coefficients, you can say cos theta divided by h by 4 should be equal to sin theta divided by k by 2 should be equal to 1 by 1, right? So from here we can say h is equal to 4 cos theta and k is equal to 2 sin theta. Therefore, the locus will be h by 4 whole square plus k by 2 whole square equals 1. So that is basically h square by 16 plus k square by 4 equals 1. And this is clearly an ellipse. This is an ellipse. The locus of h comma k is an ellipse. The eccentricity of the ellipse is root over 1 minus 4 by 16, which is going to be 3 by 4. So root 3 by 2 is the eccentricity. So basically, two of the options are right. Option B and option C are right. It's an ellipse with eccentricity root 3 over 2. Right. Let's move on to the next problem. A variable chord, PQ of parabola y square is equal to 4x is drawn parallel to y is equal to x, then which of the following points lies on the locus of the point of intersection of normals at P and Q. Okay, so the options are 7, 2, 6, 3, 7, 4, none of these. So first of all, you have to understand what the question is saying. There is a variable called PQ of the parabola, which is drawn parallel to y is equal to x, right? So the slope of the variable chord should be 1, right? Now we have to find the locus of point of intersection of normals at P and Q. Now this is a standard result. If you have 2 points P, a t1 square 2a t1 and Q, a t2 square 2a t2, the equation of the normals is tx plus y is equal to 2at plus at cube. And if you draw the equation of normal at P, which will be t1x plus y is equal to 2at1 plus at1 cube, and at Q, which will be t2x plus y is equal to 2at2 plus at2 cube, and then solve it, the point of intersection of the normals will come out to be point of intersection of normals. This result is something that you can remember also, just like we remember point of intersection of tangents, right? It will come out to be a t1 square plus t2 square plus t1 t2 plus 2 comma minus a t1 t2 t1 plus t2. This is the point of intersection of normals at two parametric points. If you don't want to remember the result, you will have to solve this equation with t1 and t2 and find these points, right? Now, this is what they're asking, locus of the point of intersection of normals at P and Q. So our point P and Q can be taken like this. Here A is 1. So therefore, if I say the point of intersection is h comma k of the normals, then h should be a is 1. So h should be t1 square plus t2 square plus t1 t2 plus 2. And k should be minus t1 t2 into t1 plus t2. Right? These are my values of h and k. Now, also another thing was given that the chord PQ of the parabola has slope equals 1, right? Now we discussed in the theory that any chord of the parabola joining two parametric points a t1 squared 2a t1 and a t2 squared 2a t2, we discussed that the slope of the chords you should remember. The slope of the chord is 2 by t1 plus t2. This is a fact that is very important to remember. So here we can directly use that. Here it is saying slope of chord is equal to 1, which means 2 by t1 plus t2 equals 1, which means t1 plus t2 equals 2. So that is an additional piece of information that we know. And our locus was using these points. H is t1 square plus t2 square plus t1 t2 plus 2. And k is minus t1 t2 t1 plus t2, right? So now because we know t1 plus t2 is equal to 2, we can easily convert this and write it as t1 square plus t2 square whole square minus t1 t2 plus 2. What have I done here? I have written this three terms as t1 square plus t2 whole square minus t1 t2. So we already know t1 plus t2 is 2. So this is 4 minus t1 t2 plus 2. So 6 minus t1 t2. And what is this expression? This is minus 2 times t1 t2. So obviously we get k by 2. Negative k by 2 is t1 t2. and we can put that in this equation, and we get h is equal to 6 minus negative k by 2, right? So h is equal to 6 plus k by 2. So you get 2h is equal to 12 plus k. You get 2h minus k is equal to 12, and the locus required is 2x minus y equals 12. This straight line is the locus of point of intersection of normals at P and Q. Now we have to check from the options which options make sense, and you can clearly see that 7 comma 2 lies on this line, and that concludes the problem. So this problem was about knowing how to find the locus of point of intersection of normals to a parabola, and also knowing that slope of a random chord of a parabola is 2 by t1 plus t2, right? All of this theory was already discussed, so it should not come as a shock to you. You should know all of these things. Let's go to the next problem. Question 4. It says, let a series of n ellipses be there with EI, the ellipse I, is x squared by AI plus 1 square plus y squared by AI square equals 1, where AI is an increasing GP with common ratio of 2. Okay. Now the question is saying let CI be the auxiliary circle of ellipse EI. Let distance between focus and one end of minor axis of EN be FM. So FM is the distance between focus and one end of the minor axis of EN. Length of that chord of CN, which is tangent to EN at one end of the minor axis, is L. We have to find out the value of L square by FM square. So the question looks complicated, but it's actually pretty simple. We have CI is the auxiliary circle of ellipse EI, right? So right now our focus is ellipse EN. So what is the equation of ellipse EN? The equation of ellipse EN is x squared by AN plus 1 square plus y squared by AN square equals 1. And we can calculate the eccentricity of the ellipse. It will be 1 minus AN squared by AN plus 1 square. And remember that AI was an increasing GP with common ratio 1, a common ratio 2. Therefore, AN by AN plus 1 is 1 over 2, right? Because AN plus 1 was the next term after AN. So that will be 2 times AN. So this will become 1 minus 1 over 4 because it is 2 square. And therefore, this is root 3 over 2. That is the eccentricity of my ellipse EN, right? Once I know the eccentricity, what I can do is I can find the points, find the focus, find the endpoint of minor axis and so on, right? So let's do that. So let's say we have an ellipse like this. So the question is saying distance between focus and one end of minor axis of EN is called FM. So focus is here minus AE comma 0. Minor axis of ellipse is 0 comma B. Ellipse equation was like this, right? So you can easily see that B is equal to AN here, right? And this distance is known as the distance FM, right? So this distance is actually easy to find. It is simply Pythagoras theorem B square plus A square E square, right? And what is B square? B square is AN square. What is A square? It is AN plus 1 square. What is E square? We found E as root 3 over 2, so that is 3 by 4, right? Now remember, this is AN square plus AN plus 1 square is 4 times AN square. So multiplied by 3 by 4, you get 3 AN square. You get total of 4 AN square. That is equal to FM square, right? So FM is equal to 2 AN. So we are doing simple distance formula to find FM, right? Okay. Now the next part of the question is saying length of that chord of Cn. What is Cn? Cn is the auxiliary circle of this ellipse. So auxiliary circle equation would be x square plus y square is equal to an plus 1 square, because auxiliary circle is on the major axis, right? So major axis is the an plus 1 square axis. So this is my auxiliary circle. Length of that chord of Cn, which is tangent to En at one end of the minor axis, is L. One end of the minor axis is this point, and let's make a tangent to En here. So the tangent equation would be like this. If you write the tangent equation at this 0, b point, you will quickly realize that the tangent equation is y is equal to an, right? You can put that here. 0, b is my point of tangency. X1 by an plus 1 whole square plus y1 by an square is equal to 1. But x1 is 0 and y1 is an. So therefore it becomes y is equal to an line. And we want to find out the length of this chord in the big circle, right? So remember that that can be easily found because we know this distance is b and this is the radius of the circle. Radius of the circle is an plus 1, right? So this distance by Pythagoras theorem is root over an plus 1 square minus b square. But b was an, so this is an plus 1 square minus an square. And an plus 1 square is 4 times an square. So this is root over 3 of an square, right? So this is root 3 an. But this is just half of the chord. So double of the chord would be 2 root 3 an. So we are getting length of the chord L is 2 root 3 an, right? And now we have to find out L square by Fm square, right? L square will be equal to 12 an square divided by Fm square will be equal to 4 an square. And therefore our answer is 3. So 3 becomes our answer, and this problem was not at all difficult because we knew that the sequence was a GP. We knew the ratio of an plus 1 square and an square, and we just wrote the ellipse equation. We just wrote the circle equation, which is the auxiliary circle, and figured out the relevant distances by simple drawing a diagram and using Pythagoras theorem. So even if the problem looks complicated, you should not think that it has to be difficult. It's not necessary that the problem will be very difficult, right? Okay, let's move on to the next question. Question number 5. In this question, we have let a parabola have the equation y square is equal to root 2x. Now from a point where its directrix intersects the line, line equation is 2 root 2x minus root 2y plus 3 equals 0. A normal to the parabola is drawn. Meeting the parabola at M, which is the foot of normal, and at N. Now they have said R is the point of intersection. R is point of intersection of tangent at M and chord ON, where O is origin. If angle MRN is equal to theta, we have to find out mod of tan theta. Okay, so first things first, if this is my parabola equation, I can clearly see that y square is equal to 4ax. So a must be equal to root 2 by 4 or 1 over 2 root 2. A is equal to 1 over 2 root 2 here, right? Okay. Now, what is the equation of the directrix? Directrix equation would be x is equal to minus a. So x is equal to minus 1 over 2 root 2. And we have been told that the directrix intersects this line. So when you put this directrix in the line here, you get minus 1 minus root 2y plus 3 is 0. So root 2y is equal to 2. So y is equal to root 2. So the point that we are talking about is the point minus 1 by 2 root 2 comma root 2. This is the point, let's call it P for now, from where you will be drawing a normal line to the parabola, right? Now think about it. You have a parabola like this, and y square is equal to root 2x is the equation of the parabola. Your point is minus 1 by 2 root 2 comma root 2, somewhere here, P. Minus 1 by 2 root 2 comma root 2. And from here, you draw a normal to the parabola. At this point, it is normal. And it cuts the parabola again somewhere. Let's say it cuts it here. So this point is becoming my M, and this point is my N. And this is origin, right? So chord ON is also drawn. Chord ON is also drawn. And ON and tangent at M would be this line. They will meet somewhere at R. So the figure is not very clear because I'm drawing it by hand, but that is the main idea. The tangent at M intersects chord ON at R, right? And you have to find angle MRN, MRNN, right? Okay, this is tangent at M and this is chord ON. And the point from where the normal was drawn was this point, right? So first of all, equation of normal to a parabola is y is equal to mx minus 2am minus am cube. And this normal, basically, we know here that it passes through minus 1 by 2 root 2 comma root 2, right? And a in this parabola is 1 by 2 root 2. So the equation of the normal, if you think about it, will become root 2 is equal to, we are saying it passes through this point. So root 2 is equal to m into minus 1 by 2 root 2 minus 2 times 1 by 2 root 2 m minus 1 by 2 root 2 m cube, right? So 2 root 2 can be multiplied on both sides. You will get a 4 is equal to minus m minus 2m minus m cube. So we are getting m cube plus 3m plus 4 equals 0. And you can clearly see that m is equal to minus 1 is a root. And there are no other real roots. You can check that. We can factorize this like this. It will become m square minus m plus 4 multiplied by m plus 1. So m is equal to minus 1 is only real root of this cubic. So if m is equal to minus 1 is my real root for this cubic, I know the slope of this normal line, that is minus 1. An equation of the normal line becomes y is equal to minus x minus 2a into minus 1 plus a. So it becomes y is equal to minus x plus 2a plus 3a. X plus y is equal to 3a, 3 by 2 root 2. That is the equation of my normal, right? Although I don't need it, I'm just showing you the equation. Now, you know that the foot of this normal is the point am squared comma minus 2am, and that should be the coordinate of my point m, right? So putting the value of m as minus 1 and a as 1 over 2 root 2, we get the coordinate of m as 1 by 2 root 2 comma 1 by root 2. This is the coordinate of m. And what is it in terms of a parametric point? This would be a t1 squared comma 2a t1, but a is 1 by 2 root 2 t1 squared and 2 times 1 by 2 root 2 into t1. So this corresponds to this, and you can clearly see that t1 must be plus 1, right? So this parametric point is t1, which is plus 1. And we have to find where the normal cuts the curve again, right? If the normal at T1 cuts the curve again at a point, that point is given by T2. We have learned a relation between T1 and T2, and that relation is T2 is equal to minus T1 minus 2 by T1. This is the point T2 where the normal at T1 cuts the parabola once more. So now putting the value of T1 as 1, you get minus 1 minus 2 by 1 is equal to minus 3. So T2 is minus 3, and therefore the point N, the second point, is coming out to be a T2 square comma 2a T2, where a is 1 over 2 root 2. So N comes out as 9 by 2 root 2 comma minus 3 by root 2, right? Now, remember, we have to find the angle MRN, right? And it was something like this. It was the angle between the tangent at M and the chord O to N, right? This was the situation. This was my R, right? R was the point of intersection of the chord ON and the tangent at M, right? So if you recall, we got slope or equation of normal had come as x plus y is equal to some constant. So slope of normal was minus 1 clearly. So slope of the tangent line is equal to plus 1. We know that now. So slope of this line, RM line, which is plus 1. And now we can find the slope of ON, which is the chord. And N point is already known. So slope of ON is minus 3 by 2 root 2 divided by 9 by 2 root 2. Actually, it is not minus 3 by 2 root 2, it was minus 3 by root 2. So we get this slope as minus 2 by 3, right? And the other slope of this line is 1 plus 1, and the slope of this line is minus 2 by 3. Therefore, tan theta, which is the angle between them, is going to be 1 minus minus 2 by 3. So 5 by 3 divided by 1 plus minus 2 by 3. So 1 by 3 and modulus of that, which is 5. So the required answer, which is mod of theta, is coming out to be 5. And that finishes off our problem, right? So remember what we used here? We used the standard equation of normal, y is equal to mx minus 2am minus an cube. We also figured out that if the normal intersects a point t1, if the normal at t1 intersects the curve again at t2, we have the relation t2 is minus t1 minus 2 by t1. These two things were enough to solve the problem, right? Okay, let's move on to the next question. Question 6. If a pair of variable straight lines, x square plus y square plus x square plus 4y square plus alpha xy equals 0, where alpha is real, cuts the ellipse cuts the ellipse x square plus 4y square equals 4 at 2 points A and B, then you have to find basically the locus of point of intersection of tangents at A and B to the ellipse. Okay, so let's think about how we will do it. So we have a standard ellipse x square by 4, ellipse equation is x square by 4 plus y square by 1 is equal to 1, right? This is my ellipse equation. The center of the ellipse is clearly origin O, and these are my pair of straight lines. So notice that the pair of straight lines equation is looking like this, and there are no x, y, and constant terms. So this is a pair of straight lines through the origin. Through origin. So we might have one straight line like this, one straight line like this, and these intersect the ellipse at A and B, right? And the equation of this pair of lines is x square plus 4y square plus alpha xy equals 0, right? We have to find the locus of point of intersection of tangents at these 2 points, right? So we have to find locus of this point P, which is h comma k, right? Now, one thing that you can do here, you can write the chord equation of AB. Chord AB is chord of contact with respect to point P, which is h comma k. Therefore, that will be xh by 4 plus yk equals 1. That is the equation of my chord AB, right? Now, chord AB is like a line that cuts the ellipse at 2 points A and B. So a line cuts the curve at 2 points A and B. Can we find the equation of pair of straight lines from the origin to these 2 points A and B, right? So now think about it. This is a standard method that you have learned in pair of straight lines chapter. Whenever a line cuts a curve, the equation of the pair of straight lines joining origin to those 2 points of intersection can be obtained by homogenizing the line equation with the curve equation, right? So we have this line and we have this curve, and we'll homogenize it to find the equation of pair of straight lines OA and OB, right? So the way to do that would be look at the ellipse equation is equal to 1, and the line was hx by 4 plus ky by 1 equals 1. So we can say that it is equal to hx by 4 plus ky by 1 whole square. This is the homogenization method. I have discussed it before in the channel, and I will cover it again when we do straight lines shortly. Okay. So if you simplify this equation, you will end up getting h square minus 4 by 16 x square plus k square minus 1 into y square plus 2kh by 4 into xy equals 0. And this equation after homogenization represents the combined equation of the pair of straight lines OA and OB. But the problem has already told us that it should be x square plus 4y square plus alpha xy equals 0, right? So therefore, these two things must be identical, these two equations. So we can compare coefficients and say x square minus 4 by 16 divided by 1 is equal to k square minus 1 by 4 and is equal to hk by 2 alpha, right? And from here, we can easily see that x square minus 4 by 16 is equal to k square minus 1 by 4. So we are getting 4 here, and you are getting 4 k square minus 4 is equal to h square minus 4. So h square is equal to 4 k square. And the equation of the line pair of straight lines is x square minus 4 y square is equal to 0. No, this is the equation of the locus of the point P, h comma k, which was the point of intersection of tangents. So this becomes my locus, required locus, and that should be the answer. Now, what we did here was homogenization. We had chord of contact equation, and we are doing homogenization of that chord of contact with the ellipse equation to get the equation of pair of straight lines OA and OB. And since the problem had already given us that equation, we can compare coefficients now, right? That gives us the locus of the required locus that we need, right? Okay, let's move on to the next problem. Question 7. It says origin O is the center of two concentric circles with radii A and B, where A is less than B. A line OPQ is drawn to cut the inner circle at P, outer circle at Q. Outer circle at Q. Now PR is drawn parallel to y-axis and QR is drawn parallel to x-axis. Locus of R is an ellipse which touches both the circles and the foci of this ellipse lies on the inner circle. Find its eccentricity. That is the question. Okay, so a lot of information is given. We have to slowly do the diagram and then try to understand what is happening, right? So we have an inner circle of radius A and an outer circle of radius B. Or maybe I'll do the diagram in the next page. So let's draw our situation. Inner circle of radius A, and we have an outer circle of radius B, and both the circles are center is the origin B, and this radius is A, right? Now a line is drawn. Let's say the line makes an angle theta with the x-axis. Let's say the line is drawn like this. This angle is theta. This is O, and this is P, this is Q, right? Okay, so the line equation, line is making theta angle, so this point P would be what? A cos theta comma A sin theta, because the inner circle has radius A. And the point Q would be B cos theta comma B sin theta, right? Now there is a point R such that PR is drawn parallel to the y-axis, PR. So line through P parallel to the y-axis, right? And another line through Q parallel to the x-axis, right? So clearly R is the point of intersection of these 2 points. So notice that it will have the x coordinate of P and the y coordinate of Q, right? So the point R should be x coordinate of P is A cos theta and y coordinate of Q is B sin theta, right? Clearly, if R is this point, it will satisfy if x comma y are the coordinates of R, which are A cos theta and B sin theta. Clearly, it will satisfy this relation x square by A square plus y square by B square equals 1. And you can see that locus of R is an ellipse. Is an ellipse, right? Our job is to find the eccentricity of this ellipse. Notice here that b square is bigger than a square, so it's a upward ellipse. It's an ellipse with major axis along the y-axis, right? They also give many information. So they say that the ellipse touches the circles. It touches both the circles. So how can it touch the circles? It can touch the circle by having major axis and minor axis like this. This is a possibility for the ellipse, right? The vertices of the ellipse will be 0, comma b and 0, comma minus b. And basically, the minor axis, extremities of the minor axis will be a comma 0 and minus a comma 0. So notice that the ellipse touches the big circle at these 2 points and it touches the small circle at these 2 points, right? Also, the focus of the ellipse will be 0, comma plus minus BE, and if that lies on the inner circle, that BE must be equal to A then, right? Correct? Then only this point BE should be equal to 0, comma A, which was 0, comma A on the circle, right? So if the focus has to lie on the inner circle, then BE must be equal to A. So you're getting E is equal to A by B. And we already know the E for this ellipse would be E square is equal to 1 minus A square by B square. Because A is smaller than B. Therefore, the ellipse eccentricity will have this form. You have A square. Right. We have E is equal to A by B. And E is also equal to root over this, right? So we are getting A by B is equal to root over 1 minus A square by B square, right? Right, so that is easy only. You get E is equal to root over 1 minus E square. That is what we are getting. And E square is equal to 1 minus E square, and you get 2 E square is equal to 1 and E is equal to 1 over root 2. So that is the eccentricity of the ellipse that was required. So actually, even though the question looks long and stuff, it is pretty easy once you start the process. You make a line with angle theta, and after that you are just solving. There is no issue here. Okay. The next problem is a nice question on parabola. This is question number 8. If the equation of the tangent at P, Q, and R, PQ and vertex A of a parabola are 3x plus 4y equals 7, 2x plus 3y equals 10, and x minus y equals 0. Then we have to select the following options. Focus is 4, comma 5. Second option is length of latest rectum is 2 root 2. Third option is axis is x plus y equals 9. And fourth option is vertex is 9 by 2, comma 9 by 2. So the information that has been given to us are equation of the tangent at P, tangent at Q, and vertex A, tangent at the vertex of the parabola, right? These three equations are given. Let's draw a figure. So we have this situation. This is my A, and this is the equation of tangent at vertex, which is the line y is equal to x. This is my point P, this is my point Q. The tangent at P is like this. Tangent at Q is like this, right? The tangent at P equation is 3x plus 4y equals 7. The tangent at Q equation is 2x plus 3y equals 10, right? Let's say the focus of the parabola is somewhere here, S, right? Now, this is the point where we need to use one of the properties that we had learned during the theory. So I will do that property here again. So I will just rub this off. So look at a standard parabola. Look at a standard parabola. And this is the tangent at vertex. This is a point P. And let's make a tangent at P. So equation of tangent at P is Ty is equal to x plus at square, right? Right. And this is my focus. So now, where does this tangent meet the tangent at vertex? You have to put x is equal to 0 here in this line. So if x is equal to 0, you get y is equal to 80. So this point is basically 0 comma 80, right? Correct. Also, slope of this line is 1 over t. So that is the slope of the tangent at P. Now, let's find the slope of RS, where S is the focus. So what is the slope of RS? It will be 80 minus 0 by 0 minus A, right? So that is clearly minus T, right? So what we are getting is slope of this RS is minus T, whereas slope of the tangent was 1 by T. So clearly this angle is 90 degree, right? So basically what we understand here is if you make a circle with PS as the diameter, then point R lies on the circle, right? PS as the diameter circle, point R will lie on the circle. So basically circle with PS as diameter touches the tangent at vertex, right? Why are we saying that? We got that PR is perpendicular to RS. That is what we got, right? So because PR is perpendicular to RS, and if you take PS as the diameter, then this will be a semicircle and this R is a point on the circle circumference because angle in a semicircle is 90 degree, right? So that was a property that we have seen before. Now we are going to apply this property, okay, in this problem. So let's think about it. We have a tangent at P here. Equation of the tangent is given. Also, we have a tangent at Q. Equation of the tangent at Q is also given, right? So now, if you join this point, and let's call this point R, and let's call this point T. If you join RS, we know that RS is perpendicular to PR, right? So equation of RS should be what? Equation of RS should be any line perpendicular to PR would be like 4x minus 3y equals k, right? And we already know what R point is because that is the point of intersection of this with this line, right? So what is the coordinate of R? Put y is equal to x in this, you get 7y is equal to 7. So R is the point 1 comma 1, right? And similarly, you can find the point T also. T is the point 2x plus 3y is equal to 10 and y is equal to x. So it is the point 2 comma 2, right? So my diagram is wrong actually. 1 comma 1 and 2 comma 2 are like this, right? But we know that equation of RS is this, and since it passes through 1 comma 1, so it should be 4 minus 3 is equal to k. So equation of RS should be 4 minus 3y, 4x minus 3y is equal to 1, right? That is my equation of RS. Similarly, equation of TS, which is perpendicular to tangent at Q, right? TS is perpendicular to the tangent at Q. Tangent at Q equation has been given like this. So TS equation should be 3x minus 2y is equal to K. But TS point should pass through T2 comma 2, this line. So if you put 2 comma 2 here, you get 6 minus 4K is equal to 2. So equation of TS is 3x minus 2y equals 2. So now we know the equations of both of the lines TS and RS. And we have used the property that this TS and RS will be perpendicular to the two tangent equations, right? Now that we know TS and RS equations, we just have to solve this equation along with this equation to find the location of the focus. The intersection point of the focus, the intersection point of this and this will come out to be 4, 5. So that becomes my focus. So you can do that yourself. You have 3x minus 2y equals 2 and you have 4x minus 3y equals 1. You can see that 4, 5 satisfies both the equations, right? So that becomes the focus of the parabola. And once I find my focus, the rest of the problem is pretty easy because we know the equation of tangent at vertex A. So we have focus S is 4, 5. Tangent at vertex is y is equal to x. So perpendicular from S to y is equal to x is A, right? So therefore it will be 5 minus 4 pi root 2. So 1 over root 2 is A. So therefore length of latus rectum is 4 times A. So 2 root 2. We found that. And equation of tangent at vertex is this. So equation of axis should be perpendicular to this. So should be x plus y equals to some k, because this has slope -1, this had slope 1. And axis should pass through the focus. So 4 plus 5 equals k. So therefore equation of axis is x plus y equals 9. And once I know the axis and I already know tangent at vertex, so vertex would be the intersection point of this line, and that is clearly going to be 9 by 2 comma 9 by 2. So the entire problem is solved now, and the problem is solved because we understood and we remembered the property that if you have the tangent at the vertex like this, and if you have a tangent at a random point P, slope of the tangent was 1 by T. And if you join S to this point R, the slope of this line comes out to be minus T. So that means this angle is 90 degree here. And that property is stated usually in different ways. It is stated by saying that if you make a circle with PS as diameter, if PS is the diameter of the circle, then R lies on the circle. So you can say like this, the circle should be like this. Angle in a semicircle is 90 degrees, so it should be like this. Usually the way the property is stated is circle with PS as the diameter touches the tangent at vertex, right? And that is the property that we use to solve this problem. Okay, we can do one last problem. This is not very difficult, but we'll try it out anyway. Okay, question number 9. It says, let A and B be positive real numbers such that A is greater than 1 and B is less than A. Let P be a point in the first quadrant that lies on hyperbola x square by a square minus y square by b square equals 1. Suppose tangent at P passes through 1, 0, and suppose normal at P cuts off equal intercepts on both X and Y axis. Let delta be the area of triangle formed by tangent at P, normal at P, and the x-axis. If E is the eccentricity of the hyperbola, then which statements are true? The first statement is 1 is less than E is less than root 2. Second statement is root 2 is less than E is less than 2. Third statement is delta is equal to A power 4, and D part is delta is equal to B power 4. So this is the problem. We have a point on the hyperbola in the first quadrant. Tangent at that point P passes through 1 comma 0, and also normal at P cuts off equal intercepts on both x and y axes. Delta is the area of triangle formed by the tangent, normal, and the x-axis, right? And we have to answer these questions. So now, first of all, remember that if they have given this information, normal at P cuts off equal intercepts on both x and y axis. So then that is a lot of information actually, because by intercept form, the equation of normal should be x by a plus y by a equals 1, or equals some constant lambda, right? Because equal intercepts are being formed. So from here we can easily see that x plus y is equal to a lambda is equation of the normal, and slope of normal, slope is coming out to be -1, which also tells us slope of the tangent, and slope of the tangent will be +1 now, right? Correct? So, and tangent passes through 1 comma 0, so you will get the equation of the tangent directly. You will get equation of tangent will be y minus, passes through 1 comma 0, so y minus 0 is equal to +1 into x minus 1. Y is equal to x minus 1 is the tangent line. How did we get this? Because we got the slope of normal is -1, right? Let's say the point was somewhere on this hyperbola, somewhere here, x1, y1, right? Now, the equation of tangent at x1, y1 will be x1 by a square minus y1 by b square equals 1. And that equation and this equation are supposed to be same. So x minus y equals 1. Both are supposed to be the same tangent equation, right? So if you compare coefficients, you will get x1 by a square divided by 1 is equal to y1 by b square is equal to 1. So we get x1 is equal to a square and y1 is equal to b square. So this point is actually the point a square comma b square. And since this point lies on the hyperbola, it will satisfy the hyperbola equation, which is x1 square by a square minus y1 square by b square should be 1. And since x1 is a square, you will get a square minus b square is equal to 1 from here, right? So we are getting the condition a square minus b square is equal to 1, which means that a square is equal to b square plus 1, right? And that will help us get the eccentricity. Eccentricity of the hyperbola was, since b was less than a, it is 1 plus b square by a square. And now I'm getting a square is b square plus 1. So it is 1 plus b square by b square plus 1. So clearly eccentricity is greater than 1, and because b square by b square plus 1 is clearly less than 2, therefore we can say eccentricity is less than root 2, right? Because 1 plus something less than 2, so eccentricity will be less than root 2. So we get that the eccentricity range is this, right? Now the rest of the problem is pretty easy. We just write the equations of the tangent and the normal. they pass through this point. So we know the equation of the tangent already. The tangent equation is y is equal to x minus 1. And the normal equation, the normal will have a slope of minus 1, and it will pass through a square comma b square. So it will be y minus b square is equal to minus 1 x minus a square. So y minus b square is equal to minus x plus a square. So x plus y equals a square plus b square. That is the normal. And this is the tangent. We have to find the area of the triangle formed by the tangent and the normal. So this point is a square comma b square. Tangent line is like this, normal line is like this, right? So the normal line cuts the x-axis when y is equal to 0. So this point is a square plus b square comma 0. And tangent line cuts the x-axis at 1 comma 0, right? So this base of the triangle has length of a square plus b square minus 1. And the height of the triangle is b square. So area del is half into b square into a square plus b square minus 1. But we already know that a square is equal to b square plus 1. So if you put that here, we get equal to half into b square plus 1 plus b square minus 1. So 2b square. So it is equal to b power 4. So the del is equal to b power 4. So notice how we did the question. We said that since the normal cuts off equal intercepts on the coordinate axis, the equation of the normal will look like x by a plus y by a equal to 1. And that means its slope is minus 1. Because we knew the slope of the normal, the slope of the tangent became plus 1. And we already knew a point through the tangent. So we got the full tangent equation. Once you get the tangent equation, after that it is pretty straightforward, because then we can compare it with the standard tangent equation to get the fact that the point will be a square comma b square. And since the point is a square comma b square, we also put it in the hyperbola equation to get a square minus b square equals 1. After that, an estimate of the eccentricity can be made and also the area of the triangle can be found. That concludes this problem. Hopefully, you have learned something from these videos. We have seen that even while solving slightly advanced looking problems, you don't need to remember too many facts. Don't try to remember hundreds of properties in these conic sections. Whatever we have discussed so far is more than enough. If you utilize the theory that we have learned properly, you will be able to solve questions. You just have to be not scared of the problem and approach it in a systematic way. So hopefully you learned something from this video. Next class onwards, we'll be discussing the topics of straight lines and circles, and conic sections is more or less complete from my side. So that's what we'll focus on the next videos. So that's it for this one. If you like the content, please like the video and subscribe to the channel. Share it with your friends. I want to reach as many people as possible, and your help will be much appreciated there. Thanks. I'll see you next time.